If you haven't downloaded the Microcap 10 program, look at Diode Decimal to Binary Decoder Tutorial 1 for instructions. Tutorial 6 is a diode bridge rectifier circuit. A capacitor can be switched onto the output at node 8 by double-clicking the switch. Print out a copy to refer to when you build this circuit. Note the node numbers shown in red. We go to the transient analysis operation to see this circuit in operation. We see we're set at 0.1 second. We have two graphs, 1 and 2. We're looking at V7 and V8, which is the input to the transformer and the output to the 10K resistor. We've set the range from 0.1 seconds, starting at 0 seconds in 0.02 second intervals. We've set the input signal range between minus 200 and 200 volts and 220 volt steps. And the output we're looking at with a graph that goes from 0 to 600 volts and 60 volt steps. So we'll run the transient analysis. And there we see. That's the signal going into the transformer. That's the rectified signal coming out. When you double-click on the switch, you'll see the effect of the capacitor on the circuit. We'll go back to the input schematic. Now we need to call up the Microcap 10 simulation program and build this circuit. Again, we get rid of the tip of the day. We come in and set up our grid. We'll go look for a sine source, waveform sources, sine source. We'll place that. We'll make it 60 hertz. We'll make it 110 volts. And we'll accept that. We'll escape from there and we'll go look for a transformer. Again, analog primitives. We'll come down for transformer. We'll select that. And we'll put it in place. The coupling values are going to be 1 M, 10 M, and 0.98. We'll escape from that. We'll look for a diode. We're going to want a high voltage diode. So we're going to come down this way. We'll put the diode in place. We want to make it generic. That gives us a 500 volt diode. We'll accept that. We'll put the others in. So we got all our diodes. Now we'll look for a resistor. We'll come over here and place it. We'll make that 10K. We'll get a capacitor. Bring that over. We'll make that 100 microfarads. We'll go for a single pole, single throw switch, animation single pole, single throw. We'll bring that over and put it in place. Escape from there, and we're ready to start some wiring. So I'll go to the wiring symbol. I skipped most of the wiring for you, did it, so that you didn't have to wait on me. I hold the left button down and release it to do it. Hold down and release. That's the wiring. Now we'll put in the grounds, and that will complete the circuit. I'll put a ground there. I'll put a ground here. And a ground here. Oh, and I got to put a ground over here too. So I'll set that ground there. I'll go back and get a wiring icon and add the last wire. This should be the circuit. So now we're ready to do analysis. So I come up to the transient. We're going to have to do some adjusted values here. We're going to have to change some times. We'll make this 0.1 seconds. V1 is okay, but the output is actually node 4, so we'll set that. We want 2 graphs, so we have to make this the second graph. We won't go with the auto ranging. We'll set this at 0.1, and it will begin at 0 time, and our increments will be 0.02, and we'll do that on both of these. Our voltages here are going to be 200 as a maximum, minus 200 as the minimum, and in 20 volt steps. The other is going to be 600 volts maximum, 0 volts minimum, and 60 volt steps. And so now we are ready to try a run. And there you see the output. This is into the transformer, and this is across the 10K resistor. Of course, we haven't actuated the switch to put the capacitor in. You can do that and see what the results are. So we'll go back to the schematic. We'll exit the analysis. And there you see this simple bridge rectifier circuit. You can play with the 10K, the capacitor. You can actually add a number of other components to see what the effect is on a rectified signal.